it is our pleasure that we have an experienced person, Saurav Kumar Sharma from Techinest Private Limited, a robotics company, a well-known and reputed robotics company of Jaipur. Uh, Saurav sir, we heartily welcome you in this workshop. This is a basically faculty development program, uh, and we also thankful to ATAL AICTE for to provide the funding to organize such a great events. So without taking much time, and because everybody wants to hear from the Saurav sir, I hand over it to Saurav sir to please start.
Hi, sir. Thank you. Well, good morning, everyone. First of all, I'll thank Amit sir and the participant who have been participating into this basically, and because of that, I got a chance to interact with you once again. The session for next couple of minutes is going to be related to the sensor interfacing, right? The domain that we are discussing is embedded system and IoT, in which this field can be a foundational building block for many different functional domains in industry. It could be either healthcare, it could be robotics, it could be drone, it could be automation. So the foundation of those practical functional domains would be embedded system, where you have to have devices. You should have hardwares, you should have sensors, input output devices. So couple of things. If you combine them together, if you program them well, if you have very good structure, or maybe PCB designing with right calculations, I believe we would be having that device which we were required for that particular domain too. So since we are discussing in this session related to digital sensor interfacing, right? So there could be two directions while interfacing the sensors, right? Either it could be through microcontroller mode, or through through microprocessor mode, right? So before going or jumping onto the practical side, let's just try to understand few things, so that I don't know whether what could be your background, what could be your base knowledge, what could be your base understanding about all such things theoretically. So I'll try to cover the concept and the practical side of all these terms, right? So we'll be connecting two times, right, for this session, between 11:30 till 1:30. After a gap of 1 hour, we'll connect once again after 1 hour at 2:30, right? So I got a chance to speak for 4 hours related to digital or analog sensor interfacing. So what do we mean by digital? Why we are calling them digital? However, in real world, we would have parameters to observe, right, through these sensor, and that could be possible only in analog in nature, right? So why we are calling them digital sensors? What could be mode? What could be their specifications? Let's talk about it, right? So let me share my screen first of all, and I hope my screen is visible, sir. So it will take time, a bit of time, because I'm just trying to connect my writing pad as well. We'll try to see what kind of mode, what type of functionalities that we have in this interfacing domain, right? I'll try to start from very scratch, right? And then we'll go slowly on to developing things, understanding the internal circuitries and current flow, data flow from one end to another, and we'll see the application side of all these interfacing of sensors as well with the hardware. Just give me a minute. Yeah. So let's talk about sensor first. I think everybody of you is aware it's a kind of transducer which converts a type of energy into another energy, right? One type of energy into another energy, most probably non-electrical to electrical quantity. So here we are going to get voltage or current, right? However, we'll be getting potential only once we will have a load, right? Based on that, we'll be having, current flow towards that load, and we'll be able to measure whether how much amount of current that, that is going to be flown from one end to another, right? So moreover, in one single sentence, non-electrical quantity to be converted into electrical. So then this non-electrical parameter, it could be either pressure, it could be temperature, it could be distance, it could be light, it could be sound, right? Humidity, number of parameters in real world, right? So all these parameters are analog in nature. These are varying with time, right? These are varying with time. So first of all, any transducer or any sensor, a kind of transducer which converts your non-electrical parameter into electrical quantity, will always be in analog. So we should never assume that a sensor is digital. First of all, every single sensor initially for the first time would be analog. Means the data that we are going to receive from any such specific sensor would be an analog. Now it'll be your duty or responsibility based on the requirement, on receiving side, that either do you want to receive this data into digital mode or analog mode. However, there could be three different sections of data communication, either in digital mode or analog mode or communicating mode. So we'll discuss all three of them, right? What do we mean by digital and analog and communicating mode? And then in this session, right, between 11:30 till 1:30, we'll be going with digital one, and in the second session we'll be trying to work with analog as well, right? So I'll try to cover, if I'll get time, that to even send this data to any particular cloud, over a particular cloud also, so that we can measure our data remotely as well, right? This is what we have a function or requirement to send or to see, to monitor, to visualize our parametric conditions for any particular hardware, right? So moreover, there are three things that to be discussed, and we have understood non-electrical quantity, any particular parameter which is analog in nature. Pressure will always be continuous in nature, right? So suppose this is what we are getting the graph, right, for any specific parameter, either temperature or distance or whatsoever, right? You can never tell whether light is digital, right? It's never day and night, but still, right, we always talk about day and night, since if even a small sunlight is available, that is day. If it is not, then it is night, right? So based on the threshold values, if we'll just set up a threshold here, right, so we can discuss either the values, the voltages which are lesser than this threshold, suppose VTH, right? Lesser than this VTH would be considered as 0, and more than that will be considered as 1, means high or low. So based on which we can discuss whether we have digital sensors or digital data coming from the actual sensors, right? So let's talk about it a bit more, right? Suppose you have this data in analog form, right, like this, that is continuous in nature with respect to time. This is what we have voltage, right? Now what will happen, there could be n number of nature, right, of your data to be coming or to be converted from analog to digital, right? There could be n number of methods. The easiest method that you can find out in sensors would be comparative comparator, right? So comparator, you must have heard about op-amp, right? Operational amplifiers. And there is a function of op-amp that will be a comparator, right? Maybe you could have subtractor, adder, all such, such hardware is possible through op-amp. So one specific IC specifically meant for comparator only, right? So that IC has a role, right? That IC has a role, or you can say, you can consider any component, any electronic component, right, which has a role just to compare two voltages, right? It has a role of comparing two voltages, that is V1 and V2. Consider this is your V1 and V2 is your threshold. V2 is actually VTH, right? V2 is VTH and V1 is your analog actual data, right? So it will compare this, electronic IC or component will compare both of these voltages, and after comparison, the output will be coming either high or low, right? So we have to always think, do we really, depending upon our requirement, do we really need digital data or analog data? Definitely digital matters a lot in many practical use cases. For example, suppose this is what we have, conveyor belt, right? This is our conveyor belt, right? Here the products are coming, right? The boxes are coming, and here the sensor is placed, right? Through the sensor, we have to just check whether how many products are being passed through this conveyor belt. We have to count the number of products, right, being manufactured, right? So after manufacturing, the products are coming up, and this sensor is counting the number of products being sent through this particular conveyor belt. So here one single sensor which will just sense whether the object is available or not, right? This object is available or not. So object detection without camera, without artificial intelligent algorithms, right, or machine learning algorithms, just with the hardware, with one single sensors, right, just to check whether the object is coming towards this conveyor belt from A side to B side, right? So we have to count. So object can be detected based on the, suppose sensor is here and we have to check the distance. If no object is there, so distance will be more. If distance is less, then object has been passed out, right? So in this mode, only we need digital sensors. We don't require any analog one, right? We don't require any analog one. But if we really want to check, like in home automation, suppose we're talking about uh, you know with respect to sunlight, our home light should be on or off, plus intensity should be controlled automatically. So based on the sunlight, if sunlight is getting down, means in evening time there would be low intensity of light, and based on the requirement, based on the sunlight itself, right, the intensity of that room automatically be controlled, right? Likewise, in our street light, I'm taking too much examples just to make you understand. In real time, definitely, both of these conditions matters a lot for us. Sometimes, depending upon requirement, we have a need of digital sensors, and sometimes we need a analog sensors, right? So actually, the nature of sensor would be in analog form, right? And that could be converted very easily using comparator. That could be an electronic component. It could be an IC which will just compare two voltages, but one is the real voltage which is coming from a sensor, and the second one would be the threshold value, which will just convert our data into high or low, right? So now your data which is high or low would be either 1 or 0, right? Either 1 or 0, that could be fed. Finally, this is sensor, right? After comparison and everything, the sensor is giving either 1 or 0. Now this data could be fed into either any microcontroller or microprocessor kind of hardware, which can process your data, which can process your information. So this is your another IC, this is your another hardware, right, which will process your information which is coming from sensor. So sensor is detecting either 1 or 0 depending upon, suppose we are talking about temperature. Temperature is high, right? Temperature is above, threshold. Suppose our threshold value is 30 degree. So whenever temperature is crossing 30 degree, automatically sensor will give 1 to microprocessor or microcontroller, and based on that, what do we want? We can take an action. So action could be either to raise the siren, right? Raise the buzzer. Suppose there was a boiler, right? So we can take an action. We can control this boiler. We just try to turn off this boiler. We can send this data to a cloud also, so that somebody else can monitor remotely as well, right? So we can take any action. This will be the pipeline. You can understand this will be our product use case pipeline, right? And this pipeline just starts from the sensor itself. Okay, so nature of understanding about the nature of sensor is very much important for us, right? Now let's talk about how many sensors and how can we even get the sensor conversion from analog to digital in nature. Okay, and also we'll talk about this microcontroller and microprocessor kind of thing. Okay, let me just take an example. Suppose I have a sensor here right now, that is sound sensor, suppose, right? You can have LDR sensor, light dependent resistor sensor, which will detect your light. Likewise, you can have IR sensor, infrared sensor, which may detect light, which may detect distance as well, right? You can have ultrasonic sensor also, right? So there are number of technical names, number of technologies that we have available for actually building our sensors or getting our values in real time for the real environmental parameters. So right now I have a couple of sensors. I'll show you with my camera also. Right, I have humidity sensor, temperature sensor. I have sound sensor. I have IR sensors. I have a couple of other sensors, with me right now. Okay, so let's take an example for sound one, right? So I have a mic here. This is mic, right? So the role of this mic is there are two terminals of this mic, right? We used to provide a voltage here. We used to give maybe suppose ground here, right? This is ground, and this is suppose I provided 5 volt. So what will happen if I'll just provide 5 volt? So this mic will take voltage input directly here. Okay. So what I did, I have just connected a resistor here, which could be called as pull up or pull down resistor. So if I connect my resistor here on ground side, it will be called as pull down. And if I've connected this resistor here on 5 volt side, it will be called as pull up resistor. So RP, right? So I have a resistor here, and this is my terminal. So this is my terminal. Suppose data terminal I'm talking about. This is data terminal. So as soon as any sound in real environment would be available, any noise, any sound, any spike would be available based on the intensity of the sound. This mic is going to convert that particular sound into some voltages, right? Right? That sound into voltages. So right now, my data which was available was 5 volt, because here I had 5 volt, right? As soon as as soon as I'll just see, okay, there's a roll of some voltages here. Either this voltage can be increased, or it could be either 5 volt. Okay, it could be either increase or it could be 5 volt, right? Just try to see this understanding. I mean, I'm just trying to talk about whenever the pitch label or whenever the sound is available in the real environment, there would be a change on this terminal with respect to sound, and in the form of voltages. Now this voltage suppose is actually changing from 5 volt to somehow 3 voltage 4 volt. sorry, 7 volt or 6 volt, right? This is what I'm just, making you assume, or making you visualize about some hypothetical terms or conditions. So overall, what you've understood, that you are going to get some voltages here. You're going to get some values here, right? Okay. Now you have to decide whether what should be your threshold value. 5.5, 5.8, 5.9, whatsoever. Suppose you have 5.9, a voltage level, right? You could give here 3 volt also, doesn't matter, right? You can give here 3 volt also. So you can just consider any particular threshold value, right? Suppose with respect to 5, I have just decided, okay, my threshold level must be 5.9. Okay. And now the comparator output here after comparison, right? Because this data is going in V1 and we have decided 5.9 value of V2. Now this comparator will give either 5 volt or 0 volt. The role of this comparator is just to give either 5 volt or 0 volt, right? As soon as there'll be any spike, any spike of sound, immediately I'll get 5 volt. And if there is no sound, there is just a small noise nearby the environment or in the environment, you'll be getting 0, right? Okay. So if we are getting 5 or 0, right, 5 volt or 0 volt, right, from this comparator, overall, if we'll consider like this is the final sensor, right, we are getting 5 volt or 0 volt. Now our role is just to receive this data properly based on the input, right? Based on the input, any spike is there or no spike is there, 5 or 0, here on microcontroller or microprocessor. So what should be our consideration? What should be our requirement, final decision before selecting? So should we go with microcontroller or should we go with microprocessor? Okay. So let's try to understand both of these also once. So microprocessor, what I'm talking about, what do we mean by microprocessor or microcontroller? Let's try to understand that. So if we are talking about microcontroller, it could be either Intel microcontroller, microcontroller, microchip, right? It could have Atmel microcontroller. It could have ARM based microcontrollers. It could have ST microcontrollers, right? So these are the name of the companies or series. Basically, you can understand that these are the series, right? So or you can say companies also. Every company like ST Microelectronics, they're making multiple microcontrollers, and there is a microcontroller name, suppose uh, MP001, right? So this is one of the IC only, okay, right? This is one of the IC only. So every different architecture would have number of ICs available. Which one would be good? Which one is right for us? Depending upon application, we can decide whether, because every single every single IC would have inputs, outputs, and extra pins, right? What are these extra pins? It could be communicating pins, or it could be having VCC and ground pins, right? Power pins, or you can say, right? So in VCC and ground, there could be two level once again, either 5 volt, either 3.3 volt, right? Some of the ICs would have 1.5 volt levels as well, right? Since my mobile phone used to work on 3.3 volt itself, and many industry standards are working on 5 volt as well. So microcontroller, these based on these series, you can have any microcontrollers. If you talk about open source, we can have Arduino based microcontrollers, or Arduino based uh, you know microcontroller boards, right? These are boards, right? So Arduino has different boards based on different requirement. Once again, like it could have either input output ports only, it could have Wi-Fi available as well. It could have Bluetooth also available. It could have some more extra functionalities or pins available for GSM connections, for GPS, for fingerprint, for communicating devices, right? So Arduino, based on our requirement, we can decide which Arduino board that we should purchase. So it's an open source platform, right? Even a small kid, right, a kid of 10 years old, till a person who is working in industry and really, he is working in research, they're all working on Arduino nowadays. The beauty of this Arduino is to work with digital and analog data both, right? It can work with both of these directions, right? So Arduino has I'm not just going with the Arduino, right? I'm just trying to explain you about the difference between both of these things, Arduino and Arduino and microprocessor direction. So Arduino, the basic board that you will purchase, or you can just find out in Arduino section, would be Arduino Uno, right? And it could have ESP series, which will have Wi-Fi and Bluetooth available. Like you have ESP 8266. This is one of the finest IC or a chip available in the market, just in 150 rupees, I guess. And it's fabulous to work with it, right? You can use it directly in any particular, product, wherever you need any Wi-Fi or Bluetooth signals to capture, right? It is so fast, right? Uh, since 8-bit microcontrollers till 32-bit microcontrollers are available, right? So depending upon your requirement, again, whether do you want to process high amount of data, or just just a digital data of 1 bit, you can decide whether which board in our Arduino section should you choose. But since it's a open source, so production with this Arduino is not, it's not that good, because somebody else can hack your hardware. Somebody else can actually look out your architecture level of this Arduino section, right? So then people do research upon this Arduino, and the ICs which are used inside this Arduino is Atmel based. So Atmel microcontroller company, or Atmel chip company, has been already sold out, or it has been purchased by Microchip itself, right? So now Atmel is working under Microchip. So you can purchase any of these boards, and start working with digital or analog sensors, right? Now let's talk about microprocessor based things. So ARM is one of the microprocessor thing which you can just start with it, right? You can use Jetson is a hardware, a board, right, being prepared by one of the organization for multiple purposes. So why do we need microprocessor when we had microcontroller thing, right? So microcontroller is meant for specific applications where low bandwidth, low data is required, low data transmission is required, low data communication, or slow process communication is required, right? Slow process means, like, if you have, suppose, 100 MB data, right? 100 MB data, why will you get 100 MB? Since you have camera, right? You have camera interfacing, you have mic, uh, maybe sound drivers interfacing, right? You want to work on voice processing, you want to work on image processing, right? So at that time, microcontroller, either Arduino or any microcontrollers, will not be good. They'll not be able to process your data in real time, right? It will take a lot of time to process data through Arduinos. That's the reason we should just start working with microprocessor kind of thing. So either you can use ARM architecture, Jetson, and again, here also we have open source things, right? So Jetson is also a hardware where you will get operating system, OS. Here there is no operating system. Once you have just programmed microcontroller, it will continuously run until or unless there is no external output, or control has been given. If you remove power from microcontroller, it will just turned off, and if you will connect your power to this microcontroller, it will turn on, right? Now microprocessor thing. In microprocessor, you need OS first of all, operating system. Like we have operating system, Windows operating systems, right? Mac operating system, Linux operating systems, right? So you need operating system. Jetson and all these ARM-based microprocessor hardwares. Again, there are boards, right? You have a perfect circuitry available, and these are open source and closed source both, right? So you can choose any one of them, but you need operating system first of all for that, right? So most of the time you will get Linux based operating system here, right? Linux based operating system. So we have a hardware called Raspberry Pi. Similarly, Arduino we had. In Raspberry Pi, there are two things, the two important things that we have. It's a mini computer. You can say it's a kind of motherboard of your computer, right? Motherboard in a comprised form in your hand, right? So you can do all such operations like in your computer. You can do everything, whatever you can imagine, everything, whatever you're doing on computer or laptop, everything could be done with Raspberry Pi. And else, one important thing was that it has given us a chance to connect the sensors also, or peripheral devices as well. Peripheral devices means like any specific component in electronics section which we want to program, right? So you can program that particular sensor as well, right? And the best part was, because since it's working on a particular operating system, and since operating system can give you liberty of working with any programming language also. Programming language, see here, in Arduino you'll be working with either assembly language or embedded C, right? Both of these are very tough, or definitely tough compared to the other programming languages, like in open source microprocessor based boards. In Raspberry Pi you can work with Python, right? Python is one of the easiest language, right? You can start very easily with this, right? Any beginner nowadays should start their programming world, or programming things with Python only. The reason behind is it's a very high level language, right? It's not VHDL. It's very high level language which is very easy to understand. The concepts here and the writing patterns here are quite easy. And one very good thing is that Raspberry Pi supports Python, and due to this Python only you'll be able to control or work with this sensor also, or this hardware as well, right? So overall, if I'll just summarize everything in few sentences, we can either go with microprocessor or microcontroller depending upon our need. If we have high amount of data, if we have multiple informations to be sent, right, we should start working with Raspberry Pi. Or if we have a specific dedicated use case, we should work with Arduino. But if you understand both of them, like you understand Raspberry Pi and Arduino both properly, right? You should understand embedded C as well. Means this programming language along with Python as well, right? So if you understand two programming languages, and you know how to work with Raspberry Pi and Arduino, I'm sure there is no such application either with any such interfacing modules, either means voice processing modules, or camera or image processing modules, or sensor interfacings that will not come across you, right? So you can work with all those dimensions wherever, whichever direction that you imagine. Okay. One small limitation that you will find out in Raspberry Pi is, because in Raspberry Pi there is no analog to digital conversion, there is no ADC, which means if you have analog sensor, if sensor will be in analog in nature, you should not work with microprocessor, I mean this Raspberry Pi. Okay. But even though if you have analog sensor, and if you want to work with Raspberry Pi, so you should attach Arduino also with that, right? So let's try to take a case. If your sensor is digital sensor, then you can work with both Arduino or Raspberry Pi. If your sensor is analog sensor, right? So you can work with an Arduino directly. But before working with Raspberry Pi, again you have to work with any ADC and then RPi, then Raspberry Pi. Okay, you should have ADC, right? You should, if your ADC is just 1-bit ADC, then you can work with 1-bit ADC means you can work with directly comparator here. Means your data will be converted into 1 bit, either high or low. If you need more bit resolution, if you want 10-bit resolution, means your data should not be just converted into high or low. It should be converted into bits, 0 0 0 0 0 0 0 0 0 0 0, like 10 zeros till 10 ones, which means from 0 to 1 0 to 3, right, in digital form, right? So if your values are coming in 10-bit resolution, so at that time you cannot work on comparator. You should have ADC roles. You can have ladder to ladder, R to R, many different models to be converting your analog data into digital, and then you can start working with Raspberry Pi. So instead of, you can have your chip here, again another chip, another hardware, another interfacing would be required in between. Or else what you can do, you can replace, right, you can replace this entire thing with Arduino also, because Arduino has analog and digital interfacing both, right? So what I'll suggest you, if you have analog sensor to work upon, so better analog sensor, then Arduino, and then Raspberry Pi. And here what you'll do, your data will be coming from from the sensor in analog form. You have to write a program here in embedded C language, right? You will convert your analog data into digital here using embedded C, and now you will communicate that data, right? That data would be in the form of values, right, from 0 to 1 0 2 3. So you will communicate this value, you will send this value from Arduino to Raspberry Pi. Since the value is in 10 bits, so you cannot send it through one single digital IO, right? You cannot send it digital. You cannot send it digitally, you can say, right? Okay. So because since values are coming in 10 bits, you need here a communication protocol. You need communication medium, right? And to communicate your analog data from Arduino to Raspberry Pi, you need any communicating protocol like UART, like serial interface or parallel interface, or kind of interface in between Arduino and Raspberry Pi is required. So you can use either UART, you can use either I2C, you can use SPI, right? So these are the communicating protocols which you would be able to work along through Raspberry Pi and Arduino both. Okay, so this is our second use case, and this is our first use case, right? I believe you've got the complete idea. Now, did you remember, like we talked about three terms: digital sensor, analog sensors, and communicating sensors, right? Communicating sensors. So what do you mean by communicating sensors here? Okay, so any sensor, some specific sensors are available in the market, like you have or you can say sensor or any interfacing device also, any interfacing module also, they would have communication definitely established, right? So everything is same. You have analog parameter, temperature or whatsoever, sound, light, everything. Then your data has been converted into digital here. So ADC was already available in this module. This is sensor module, right? And here one specific communicating protocol was available. Suppose this protocol is SPI, right? Serial peripheral interface. Serial peripheral interface. So serially, you have to send your data from this sensor to any other communicating device, right? So now, if you have Arduino or Raspberry Pi, right? So here you should have SPI protocol. If you have SPI protocol available, then you can just you can have a handshaking between this data from sensor module to SPI port or pins available, right? Because this board has input output pins, so you can have handshaking between this sensor to this particular Arduino and Raspberry Pi port. And because of this handshaking, because SPI is a protocol supported by the sensor module and this Arduino Raspberry Pi, then you should understand how this SPI works, right? How SPI transfer, or here you will transfer data, here you will receive your data. So how do we transfer and receive a data? What will be our transferring rate, data rate, right? What will be our security? What will be our mode, right? So what will be our data in 1.0 form? So if you understand how we are sending your data, I mean your data from sensor module to this SPI, then it's quite easy to actually capture your analog or real-time data on this communicating board or microcontrollers or processor boards. And once you have data with you, right, on Arduino or Raspberry Pi, you'll be able to take action upon that. Should you store that, you can store this data, you can send it to cloud, you can just take any action to raise a buzzer, LED indicators. You can do a number of things, right? You can turn on the relays, you can turn on the maybe here actuators, whatsoever, right? So overall, what was this? It was a kind of independent board having that component which is actually receiving your environmental parameter. Then that parameter is going inside comparator or ADC, right? And then ADC data is getting communicated through any communicating protocol. Again, for that protocol, there will be an IC that protocol is sending the data in to an external world, right? Either it could be SPI, I2C, whatsoever, depending upon the mode, right? So there is a module called, suppose there is a sensor called DHT11. I believe this is one of the primary sensors mostly people use nowadays, and which has digital humidity and temperature sensor. So here there are two parameters, humidity and temperature. This DHT11 sensor, like DHT22 also available, right? So we have 3 pins, VCC, ground, and data. So only from one single pin, temperature plus humidity, both of them will be communicated, will be sent. So you have to understand which protocol is used on this sensor to send your data from DHT11 to your either Arduino or or Raspberry Pi board. So based on that particular protocol, you should receive that data on your board, and then you should capture or monitor or take actions upon that data itself. Okay, so importantly, we have digital, analog, and communicating sensors. I believe can we communicate in 2 ways? Is that possible in this meeting? Whether, let me know you guys are getting it, whether it is okay. Should I go ahead now?
Yes, sir.
Yes, sir, okay.
Okay, perfect. So I have, let me just turn on the video. Yeah. So right now I have Raspberry Pi and Arduino both. I hope the let me just stop sharing first. I hope now this will be visible in quite big picture, right? So I have Arduino and this sound sensor, right? I have this sensor connected to Arduino. It will be quite easy for me to program it. I just want to make you understand, if this is a sensor, what I'm doing, if I'm just giving a sound or a spike, even I'm speaking. So there is a LED on this sensors. However, it could be visible or not, but this LED is going to be blinked, right? This LED is actually blinking based on my voice or pitch level from the voice, right? If I'll just remove the sensor from Arduino, and I'll have this Raspberry Pi also. I have Raspberry Pi as well, right? I have Raspberry Pi boards, since Arduino is starting from Arduino Uno. Likewise, Raspberry Pi is started from Raspberry Pi 1, 2, 3, 4, and nowadays Raspberry Pi 0 is also available. So Raspberry Pi 0 till 4, there are 5 different versions of Raspberry Pi we have. Okay. So this Raspberry Pi requires a memory card, which I have connected from the backside. I have loaded my OS, Linux-based operating system into it, right? Because this Raspberry Pi is Raspberry Pi 4, which has HDMI port, which has C charging port available for giving it a power off, right? It has USB ports available. I can connect my mouse and keyboards to it. Okay. I'll be able to connect this to my router. Here in Techinist, I have my router which will I connect through this Raspberry Pi. I have not connected it yet. I'll just connect it right now, and I'll take a few minutes. So I'll just connect it through my router, and in real time I'll take control of this Raspberry Pi in my laptop. Okay, through remote desktop protocol. You must be knowing about, like we are using WebEx. uh, Through WebEx only we have Zoom available. So Zoom is being converted on one of the employee, the founder or CEO of this Zoom has learned everything in WebEx itself, and they have implemented Zoom. So uh, we have remote desktop sharing available in real time. Likewise, uh, we'll be able to load or fetch our data from Raspberry Pi to my computer. So I'll be able to program. I'll be able to write any program in Raspberry Pi. So we'll be able to interface this digital sensor, since whenever I'm just giving a sound like this, uh, it's here one mic is available. This mic is converting, giving your data, I mean the real-time data, into one of the comparator, which comparator is available here, if you can see. And nearby that we have a potentiometer. Through potentiometer I can adjust my VTH, means threshold value. Suppose I have just made my threshold value to 2.5 volt, and whenever I'm giving a sound, so this threshold, I mean the voltage level from this mic would be more than threshold value, right? So it will give us 1. Okay, so that 1 and 0 is digital in nature. We have to interface that digital data automatically or to Raspberry Pi, and let's see whether it will be possible or not. Okay, so I need 2-3 minutes, right? Let me just connect Raspberry Pi. We have to wait, because this Raspberry Pi 4 takes around 30 to 45 seconds to load, operating system. And I'll be needing, this Raspberry Pi to connect my to connect with my router, right? So just give me two minutes, right? I'll just connect it, and we'll start working on this Raspberry Pi for interfacing digital sensor. Again, why I'm saying digital, because we have just converted our analog data of sound, right, or a spike, into digital form directly with this comparator. Okay, comparator IC is available already with it. So if you let me tell you the name of this comparator also, which is very much available in the market in very low cost, maybe 2-3 rupees. IC is available. LM358, right? LM3535 is a temperature sensor, which is which works very good, very fine on ambient conditions, means in real environmental conditions. So LM35 is the temperature, LM358 is the comparator IC. Okay, so let me get 2 minutes. Okay, so I'll just join once again. I'm just taking my mic on mute. Yeah, so I have just connected Raspberry Pi, right? I've just connected Raspberry Pi. I've given the power to this Raspberry Pi. Let me just show you. I hope this screen is visible now. Right, I'm using Mac, right? So in Mac, I have just have a Microsoft Remote Desktop application. Here I have just made a setting for my Raspberry Pi. Here the connection name is Pi and the IP address for my Raspberry Pi is 192.168.1.36, right? A username is Pi and password is Raspberry, right? So I've just made this condition and I double clicked on it. So this is what I have got the screen of Raspberry Pi. Okay. Now here I have to connect this sensor as well. Okay. If I'll show you, Raspberry Pi pin configuration. Raspberry Pi 4 configurations, right? Here also we can understand. So there are 40 pins. I believe you must be knowing about all these pin configurations. We have 40 pins in Raspberry Pi, 20 in left, 20 in right, right? So left side pins are odd pins and right side pins are even pins. So 1, 2, 3, 4 like that, these pins are available. Uh, from top side, if we'll start counting, the first pin is 3.3 volt VCC, right? And the next pin, second pin is 5 volt. Fourth number pin is also 5 volt. Pin number 3 is one GPIO pins, general purpose input output pins, right? So there are overall 23 input output pins available, right? Apart from that, UART to TX, UART to RX means RX and TX pins are available for UART. For SPI also, these GPIO pins are dual in nature. They can be used for means SPI communication. I2C is also available in software mode. You can connect any specific sensor which is working on I2C as well through Raspberry Pi. So communications are available. USB port is available, so USB communication can be done through Raspberry Pi, right? A couple of other ports are available in Raspberry Pi, like you can connect your camera, you can connect your display board, right, directly. So you can connect Ethernet port as well. You can connect Ethernet connections, right? LAN power also. So LAN port or LAN, you can say protocol is also available in Raspberry Pi. So overall, these are my GPIO pins. Right now, we are talking about digital sensor interfacing. Okay. So uh, Raspberry Pi supports multiple languages. You can either work with Java, you can work with Python, you can work with embedded C as well, right? But everywhere with every different programming language, you need to work with the libraries, right, which supports hardware also. So kind of library which supports your GPIO pin connections, you can use C++ as well, right, which will be called as embedded C++. Okay. So but you should understand which library is good to go with with programming on these GPIO pins. Okay. So generally, people have preferred working with Python with Raspberry Pi due to the reason like we have library available which is quite easy to work with, and we'll be also using the same one. Okay. So I'll be connecting my sensor. With this Raspberry Pi. Just give me a second. So I have 3 pins available in my sensor: VCC, ground, and output. So output pin will be digital output pin, which will be giving me either 0 and 1, right? So I'll be connecting my output with GPIO 4, which is pin number 7, right? So I'll be connecting my output with pin number 7, right? Output of a sensor, which will be input for my Raspberry Pi. I think you can understand this sentence easily. So output of sensor will be input for my Raspberry Pi, right? And VCC in ground with pin number 2 and pin number 6, right? So let me do it right now. Pin number 6, pin number 2 or 4, and pin number 7. Yeah, so now let's start writing the program, so that, and the program which we are going to write is not just depending upon digital, sound sensor interfacing. It just for same, right? Let me take a note here, what I'm trying to tell right now. It will be same for all digital sensor. It does not matter we are using sound sensor right now. It can be any sensor. Just give me a second, please. Sometimes it takes a little time. Okay, so this is my sensor. We are not talking about specifically sound sensor. Okay, this is sensor which is getting analog, environmental data, converting into digital, and we are trying to interface digital, pins of Raspberry Pi. We have connected as the sensor with Raspberry Pi. So here a sensor is connected with pin number 7 or GPIO number 4. There were 2 more pins of sensor. Or 2 more pins, VCC and ground. So VCC, ground, and output pin. So this output is fed into this pin number 7 of Raspberry Pi. Okay, this is what we have, a small set of connection, and let's try to write the program. That's it. So this is my Raspberry Pi. You can go. This is what is the operating system, default operating system, by the way. Right, I can connect my camera also with it. I can do a lot of different things. Even I have just made few more programs for face mask detection, for artificial intelligence, intelligent model deployment, right? And then I've taken few FDP sessions as well earlier with another institutions. So couple of things are available. So here you can go in this menu option. Here we have Python 3 ideally available. Right, so Python 3.7.3. Python, there are 2 versions of Python, Python 3, Python 2. Python 2 is already stopped, right, in 2020. So we can start working with Python 3 basically. And Python 3 has a latest version as 3.10, right? And it's quite old version. I hope 3.7 being released in 2020 itself, last year itself. Okay, and every month you will see updation in these versions. Okay, so let me just write a new program for this. Okay, so we have a library called rpi.gpio. Okay, and in Python we used to really import the libraries, right? So let me import library called rpi.gpio as rp. Okay, so this is my library name. I've just given a object to it. Okay, there could be a variable which will define, which will take a reference of this particular library, right? So rp is my variable, right? So rp dot set mode within bracket rp dot board. So this set mode means there are 2 modes. In general, these GPIO pins are in deactivated mode. these pins are not activated. Since in Raspberry Pi, you can see Raspberry Pi has couple of hardwares, right? So these pins are in deactivated mode. They're not working initially. We have to activate them, and for that, there are two ways of working with them. Either BCM mode, binary coded decimal mode, or else, however, we should call it as BCD, right? So BCM mode, either you can work with BCM or you can work with board mode. So BCM means BCM follows this architecture: GPIO 2, 3, 4, right? 17, 27, 22. But board mode follows these pins, pin number 1, 3, 5, 7, 9, like this. Okay. So if I'm writing here rp.board, means I'm following board pins. Okay. I'll be writing pin number 7 instead of pin number 4. If I'll be using BCM, then I'll be using 4 here. Okay. So set mode, we have just activated the board for pin configurations, right? Physical pin configurations. And if we have to take input or output on any specific pin, we have to set up that pin also. So at rp dot setup, because we have 23 input output pins, right? So which pin that we are going to set up? 7 number pin, right? And what do we want to set up as an input? Okay, that's it. We have to take an input now. Let me take real-time input in, because once, if we'll take only one, if we'll take our input only once, then program will start, it will immediately take the input and it will be ended. So we want to take input in real time continuously, and that's why I've just made a loop, while loop, which is a infinite loop right now. Okay, so while one means infinitely it will be started working up. Let me get the data in d is equal to rp dot input within bracket pin number 7. So we are going to get a data from pin number 7, and let's try to display this d. That's it. So either d could be 1 or 0, right? So let me just write if better is equal to 1 or true. It could be called as true also. Then print sound is detected, else print no sound. However, this statement has no meaning, right? So let me just remove this. Let's try to save this program on desktop. Name that sound.py. Okay, save. If I'll run this module, sound is detected because whatever I'm speaking, it's taking some of the values. Let me just control that VTH, right? Let me just decrease or increase that VTH basically. Yeah, so now sound sensor is quite sensitive. Whenever I'll be speaking, it will be continuously going on. If I'll start, I'll stop my voice, it will stop. Okay, so to adjust my VTH properly for this sound, one more thing, I guess we're getting opposite output. Let me just use false here. Just I observed. Try to run this. Hello. 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 Can you see this? I've just observed that whenever I was just changing my VTH, right? So let me tell you that comparator output also. This is a comparator. We have V1 and V2 as also V1 and V2. So at comparator we have two things. Even if V1 is your VTH, right? And V2 is your real-time data, actual data, right? From sensor, or we can write here sensor data. Okay. The condition for this comparator is if V1 is greater than V2, then answer is 1. If V1 is less than V2, then the answer is 0. So if we'll change V1, we will just swap the value of V1 to V2, V2 to V1, right? If V1 will be sensor data and V2 will be VTH, then the output will be in reverse. So what we are getting, actually whenever I'm speaking, right, whenever sound is detected, we are getting false, means 0. Can you see this? If the sensor data, which is V2, is greater than V1, then this will be 1, otherwise 0, right? Sorry. Yeah, so if V2 is greater than V1, this is 0, and otherwise 1, right? So we are getting false automatically. If there is no sensor, if there is no sound, then we will be getting, if there is no sound, we'll be getting true. Is this okay? Did you understand that? So depending upon the connection, depending upon the your PCB connections of your inputs and outputs, you may get either 0 or 1, means high or low. You should be ready with these kind of challenges, and you should be able to understand what type of output. You should test it first, okay? And like we have tested, I have just tested, okay? Whenever I was speaking up, it was giving me 0. Whenever I'm not speaking, whenever I'm silent, it's giving me 1. So based on that, I have just written my program. Is that okay? Did you understand that? Let me write something else here. Just spoken. Hello? 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 Can you see me? Can you hear me? Hello?
Yes, sir. We can see you, sir.
No, I have just spoken to the sensor. Thank you so much for reply, by the way. So, is that okay? Let me know the response also from your side, whether if this is okay, we can go ahead then. Hello? Perfect. Now let's talk about how can we make any application out of it. Can we make any application? Do we have a... So I have made connection also with my bulb, okay? So I have made an input from the sensor, and I'll be able to connect my output through bulb also, okay? However, it will be tough to show you. Okay, so let me connect my camera also. Give me a minute. camera and show you how this. Yeah, so and this camera will try have this camera right. So I'm going to connect this bulb also with the Raspberry Pi on another pin, and we'll see whether based on the sound will that be okay, will that be on or off. Okay, so whenever I'll start speaking, the I want this bulb should be off, and otherwise it should be on, or we can do in reverse also. Okay, so what I'm going to do with this bulb, how this bulb is going to be connected with Raspberry Pi. Of course, I have another hardware, this hardware, right? This one, and this hardware has a relay, right? Hardware has a relay, so I'll just tell whether how can we connect this relay and bulb everything together. Okay, so before that, let's try to understand the connection again. Yeah, so this will be my Raspberry Pi. This will be sensor, and maybe this is your bulb. Here is my relay, and this is just a second. Suppose this is my actual AC input. Just a second, please. Just a second, please. Okay, so this is considered, this is my V in, means main 220 volt, 20 volt input. So these are two terminal. Okay, if I'll just connect this bulb directly with the terminal, what will happen? This bulb will be on. If this main switch is on, main switch, if this main switch is on, so bulb will be on. But if right, but what if I'll just connect this relay in between? How did I connect? I've just connected this terminal of main switch with the relay, and here there is a knob, right? There is a knob, to connect these two terminals directly, and this knob will be connecting if my input of this relay will be on, right? So I've just connected this relay terminal with the Raspberry Pi, right? I've just connected this relay with the Raspberry Pi. I've given here, suppose ground. I've given here ground. If I'll give one from the Raspberry Pi to this relay, now the connection between these two terminal will be established. And this is a working of relay. If separately you'll ask me to how does this relay work, I can tell you, right? So here we have suppose three terminals like this, and two terminals for output. There is a knob in between. This knob used to be connecting like this. Either you can connect through this or through this. So at a time, this knob can be connecting here or here. So what I have done, I've just connected this terminal with bulb, and I've connected this terminal with the main supply. As soon as this terminal, this knob will be switching toward this right side. And when will it be switching up? There is a coil in between pin number, suppose 1, and pin number 2, right? Pin number 1, pin number 2. So if I'll give 5 volt to pin number 1, and if I'll just give 0 volt to pin number 2, what will happen? There'll be a coil here. This coil will be energized, right? And this pin, yeah, right, this knob will be switching towards this third number pin. Suppose this is pin number 3rd, pin number 4th, pin number 5. So pin number 4 will be connecting with the pin number 3, and due to which now your main switch, main connection, main AC will be having a close connection, close path with the bulb, right? And due to which this bulb will be on. But this connection means this terminal is going to be connected with this pin number 3 only if there'll be 5 volt here on pin number 1, right? And this 5 volt is coming from Raspberry Pi, right? This 5 volt is coming from Raspberry Pi. If we will through program only, okay, if we'll control the power from Raspberry Pi, right? If we'll control the power, like we are not able to send, or we're not going to send one from Raspberry Pi, definitely there'll not be any power between pin number 1 and 2. There'll be no coil and energization, and because of which there'll be no connection, no point of contact from pin number 3 and pin number 4. Okay, so coil here in between pin number 1 and 2 gets energized, due to which magnetic field gets generated, and there'll be a kind of and this relay is called as electromechanical switch. You can understand that electromechanical switch. A bit of electronical part is involved, and a bit of mechanical part is involved. So mechanical movement of this pin, or of this knob, right? You can consider a spring here. So this knob will be switching between pin number 3 and pin number 5, right? Automatically, depending upon the magnetic field getting generated through this coil, and magnetic field is getting controlled through Raspberry Pi, right? So indirectly what we're doing, we're taking input from sensor, and we are taking action for this relay to operate or to control bulb. And here, if you'll remove this bulb, to siren, to a indicator, right? Sorry, siren, right? Any other thing, because here you can replace bulb with any output thing, because you are using 220 volts. So whatever in your home, whatever in the world is actually working on 220 volt and on AC, they on AC or DC on higher voltages, you can just connect that particular thing here itself. So you should understand how to take input and how to take action. So this is the pipeline. So in real, this sensor is taking real-time parameter from the environment in terms of sound, converting it into converting it into electrical quantity. That electrical quantity from the sensor itself through comparator is converted into digital sign, right? And this digital data is getting inside this Raspberry Pi. This Raspberry Pi is processing that data using Python, and it's taking action on relay basically to control the bulb, right? So this was the pipeline overall from here till there. Okay, so let's try to, I have to make the connection from this relay to Raspberry Pi first, and then we'll be writing a program also. Just give me a second, please. Okay, so let's try to decide which pin of Raspberry Pi we can use for this. Okay, so we are going to use pin number 9 for ground, right? Pin number 2 is for VCC, because we had 2 VCC here, and we have to choose how to give the output. Okay, so we can use pin number 11, right, which is GPIO 17. So let me use pin number 11 7 output. I'm just connecting it here also, you can see. Just connecting the ground also. Right, so I made the connection. I'll again write down here pin number 7 to take the input, pin number 11 is to get the output, right? 7 is for input, sensor input, and 11 is for relay output. And we have VCC ground, here VCC ground, here VCC ground, ground, and VCC as well. 5 volt, 0. So 5 volt, 0. Okay, that's it. We have to configure one more pin, the number 11 as output. Here we're taking input. If we have no sound, if we are just speaking up, we can write rp dot output within bracket pin number 7 as true, bulb will be on, else rp dot output bracket pin number not 7, it's 11. From pin number 7 we are taking input actually, then false. Set, we save it and run also. Hello. Yeah, so there's a problem because this bulb will not be that much fast to turn on and off the entire operations, right? So let's just take a little bit time also as t, and let me just give a delay. However, this delay can ruin entire operation as well, because delay is going to take hell amount of time to make this entire operation bad. Okay, so t dot sleep for 2 seconds, maybe 1 second for a moment. Save. I'm not giving delay to off, otherwise every time will it be in second case. You can see this. Hello. Hello.
Sir, can you show me the program, sir?
Yes, sir. So it was very simple, short. Here we had to understand couple of things. We have to keep in mind, I have not given this delay in else. The reason behind, because this while is running, and every time my else condition is running, right? So if I'll keep this delay of 1 second in else, so my sensor will be delayed whenever I'll be giving input, right? I don't know whether while giving my sound, sensor will be detecting that or not. Okay, at that time, will it be in else condition or not? Will it be in sleep mode or not? Okay, so we have to be very smart taking, writing these lines of code. However, it just like a 10 lines program, but and even these 5 lines have no meaning, right? The program is just by writing these lines only, because here we are just setting out the pin conditions or board conditions. That's it. So is that okay? Any question, anyone till now?
Can you show hardware?
Yeah. So I can show the hardware as well. Is that visible?
Yeah, block diagram, block diagram, sir, please.
Okay, yeah, that I'll also show. Okay, so here these are the pin configurations. You can see pin number 1 and pin number 11 till pin number 11 I have just connected. I'll just try to show pin diagram as well. Yeah. Let me try to write show time. Just a second, please. Okay, so Raspberry Pi. Sensor. SSC. Okay. And this is pin number 7. Output. This is your 5 volt. This is 0 volt. So so have connected. This is your input of relay. But output of Raspberry Pi. So I should change the direction of this arrow, right? Like this. This will be data flow. This will be. So just connected with the bulb. This is my main plug connected to main switch. This is my ground. This is what is VCC. And this was pin number 11. I think this is clear, right?
Yes, sir. Yes, sir.
Any question, anyone till now?
Can you we just how can I identify board is working or not actually? So I have a board, but some issue will be there. So I don't know how can I figure out.
Where exactly are you stuck in that? I mean, are you able to start with that board?
I interfaced to OS and everything. After that, it will be no display. Everything it's stuck actually. So that's the thing.
Oh,
I'm
so
not in, yeah, it's software problem or it's a hardware problem. I'm not sure about it. So that's why.
I think, have you connected your board with, I mean, Raspberry Pi board directly with the display board or your display screen with VG to HDMI converter something?
Yeah, yes, sir, yes, sir, yes, sir.
So
So I installed OS and everything.
yes.
After a few months, it will be stuck. So no input will be there. So that's the thing. I'm
So
not sure if OS or the hardware.
so you're not getting anything on screen right now, that OS, is it?
Ah, yes, sir, yes, sir.
So which Raspberry Pi board do you have?
It's 3.4 something, 3.1 or 2 something. Just forgot.
So Raspberry Pi 3 basically.
Yeah.
Okay. So do one thing, like you can just reload one another OS into another memory card and try to use it where it should be working up. Sometime it happens with the OS basically. Until or unless you're not having wrong connections in Raspberry Pi, nothing will happen with Raspberry Pi. It will always work. Or sometime, we used to do mistakes, like we used to give extra power, like we have mobile chargers right with us. So Raspberry Pi 3 does not support 3.2 ampere rating charger, right? So sometime we have high rating chargers in our home available, and we used to connect that directly. So better to be taken care of. I believe hardware should not have much problems. You should just reload your OS and then try to connect.
Okay, sir. Okay. Thank you, sir.
Any other question? Any one? Spare metal. See, I means I would suggest you can do that, but still I would suggest better to just go with OS, right? Just install your OS and try to run all your programs. Try to write your all the programs and keep them in your memory registers, so that at the time of uh, booting process, your program should be running automatically in sequence, one by one. You can make the sequence of your Raspberry Pi programs, right? In your settings, you have Raspberry Pi configuration settings. You have possibilities of taking your programs to your boot mode, right? And there could be a sequence. So better to do that instead of working with the kernel directly. So
Sir, can you explain once again the drawback of Raspberry board for analog input? I think that portion you can explain again.
yes. So Raspberry Pi does not have ADC, right? It does not have ADC. That is the bad part with Raspberry Pi till now.
Okay, so
Your
we need
you need
analog to digital converter, right?
yeah. So if you have any sensor where digital output is not coming, you need, I mean, you don't have only high or low values from the sensors to be coming up. You want your data to be coming in a range instead of digital values, right? Your data should be coming in between 0 to 1000, suppose, right? So I mean, you have to convert your data previously before entering that data into Raspberry Pi with ADC. And even you have converted that data through ADC, your direct output from this ADC will not be coming to coming and will be taken care by Raspberry Pi until or unless any communicating protocol is not implemented. So too much work on that side once your sensor is ADC and is working on analog mode. Do you have any simulation platform for Raspberry Pi?
So shortcut is we can use And Arduino to
You can use Arduino.
interface the sensor, then we can do like that, right?
Yes. You can use Arduino Nano. I would suggest it's a very easy thing, right? Use Arduino Nano. But for that, you have to understand one programming language also. You have to communicate your data from Nano till Raspberry Pi. So that's why people try to use ADC ICs as well. There are a couple of ADC.
So again, we have to C to Python again. We can.
So you have to synchronize. First of all, see, writing two programs is easy, but still you have to synchronize both of them, and that is where people find out challenges, right? And in my suggestions, better to use this Nano only, means Arduino with Raspberry Pi. If you're good to go with these synchronizations, and yes, there are possibilities once you have programming in hand now. If you understand programming, I'm sure you have power to do many things. If you are just stuck with this hardware where your data is coming automatically towards this Raspberry Pi through communicating hardware, so you have no power. You cannot do anything with this data. You can manipulate data here. You can do a lot of operations also with this data here. You can even take decisions. You can store your data. You can send your data to any memory card also, right, separately, and you can have data logger also. So better to work with Raspberry Pi and Arduino both. If we understand this, this could be called as, I'll tell you, this could be called as master, and you can consider this as slave also, right? Or you can consider this as a node also. So node to master communication, this could be a best way possible communication between hardwares altogether. And for your question, somebody has asked, Deepak sir, that do we have any simulation platform? Yes, we have. And I would suggest not to just purchase Raspberry Pi hardwares every time, because every 3 months, every 6 months you will have a new hardware coming from Raspberry Pi, and definitely we are fascinated and inclined towards purchasing those hardware, since new configuration will be coming up. They will make us prompt to purchase those hardwares initially, right? So better to start working with simulation only. You need not to waste money. So here we have a Proteus software. You can use Proteus, and latest library of Proteus can be linked, right?
Version, sir? Proteus version?
Proteus version, okay, 8 point something, like latest version is, I guess, 8.1, 8.2. So whichever version that you get from Proteus, you can find out Raspberry Pi in that. And that Raspberry Pi supports Python also. I have taken one FDP session with in association with one of the college. So there I have just been through this Proteus session only. It was for 5 days, complete one hands-on session on Raspberry Pi completely. You can use this Proteus software, and best part of this Proteus is you need not to worry virtually that either you are working, if you are required CRO or function generators, even Arduino, microcontrollers, C programming, hex file generations, Python programming, communication protocols, everything is there in this Proteus software. So better I'll suggest to go with this. Any other question, any kind of feedback that you guys have, please? And yes, we have another session next, after 1 hour. So we'll connect and we'll take this condition or this session forward, where I'll just let you know how can we communicate, because now we have taken this the action, right, just on on the bulb itself. We'll be taking the session forward to communicate this data to a cloud also, and let's see whether can we get this data live updated on our server, so that we can monitor, we can make a log of our data as well. We can further consideration of the data as well. Okay, so thank you for your inputs and your feedback. I believe whatever I have communicated, whatever I have delivered, shared, You must have understood those points. I started from very scratch. I didn't know whether what was your label. Maybe I could have just invested or wasted your few minutes of time initially while talking about few internal and microcontroller microprocessor thing. I'm sure you must be knowing all those things earlier. So, but that may have set the ground of understanding, like from where exactly and how exactly are we making the difference between Raspberry Pi and Arduino altogether. So let's meet once again after 1 hour. And if you have questions, you can ask me now. Any question, anyone, please? No? Okay, so meanwhile, I'll do one thing. Okay. Um, I have 5 more minutes to tell something. There's a platform called, since I'm running a company, right? I'm running a company from last 8 years, the name called Techinist, right? So we have made an online e-learning platform with a name called Learn and Build. Okay. So this is me itself with the with the students. Like we had great sessions on couple of technologies. I used to speak upon artificial intelligence and machine learning as well, connecting with IoT and robotics. So I worked quite a lot for robotics and 3D printing and drones. So the thing is, like here you can go and course called Learn Python Programming. If you really want to learn from scratch, we have designed this syllabus or program, which is free of cost for you, right? You have to just enter one, like you suppose enter here. Definitely there's a fees for the students, right? So I'll just provide you one coupon code so that if you'll enroll here, you'll be able to enroll and learn all those things, including projects also in Python, right? Couple of project network reachability and couple of things are there in this course, right? Everything is practically hands-on. We tried of starting this course recording. It's a recorded course, self-paced course. There are a couple of assignments and assessment. If you'll complete, there are 3 assignments. There are total 45 questions. If you can complete those questions, I'm sure your level of learning, I can consider it to be around 7 to 8 in Python out of 10. Okay, so whosoever wants to learn Python programming, it could be done. It could be easily done through this course. You need to just go on learnandbuild.in. This is a platform. You can search it on Google also. Okay, and just go in course, click on learn Python programming, and couple of other courses are also free of cost. Okay, so Docker, Kubernetes, Linux. If you want to learn Linux completely, right? So it's available here. Okay, right from very scratch, like OS installation, which OS kernel and all those things. You can just learn everything here. Speech processing, deployment of machine learning model. Couple of things are available. Filter vision, right? So it's just a pre-learning, beginner level learning for any newcomer, either in any age comes up to be. So we tried of recording this course. Like let me show you a glimpse of this course also. Let's try to log in ID. You'll get to know how many attempts that you have gone through. You'll be able to generate certificate of this learning as well automatically. I'll go to my learning dashboard now. So this is my course, right? Learn Python programming. Okay. I click on this. I've just completed 33%. How much percentage that you are covering? What exactly you know you are watching, right? How much percentage of this course has been completed, or assignments are completed? Everything is being monitored, and you'll be getting the stacks off. There are around 3,000 students or 2,600 students or learners, not I'll say students, learners are available on this course. we used to provide support session also for this. Okay, here you can just go on these modules. Everything is available here, including projects also. Okay, you can evaluate your learning through assignment and assessment. Okay, through assessment you'll be able to download the certificate here itself, right? So suppose I'll resume my learning. Even you can have hello, welcome to Learn and Build. This is sentences. Try to know the words, and for words, the ABC. Now, we tried of making it as easy as possible with all such graphics, which was good to explain the concept about. So you can go with the entire course curriculum. Even there is a project called remotely access any PC using network protocol, right? How can we have a handshaking between couple of computers together? So port reachability, networkings, IP address mechanism through Python, right? So and even good to know about GitHub. How can you use GitHub basically, and how can you prepare your GitHub profile? Everything is there. So I will suggest you please try to go with this. Whosoever is interested, learning Python, and you are struggling, maybe on YouTube. It will be quite easy. We can connect through sessions. We can connect. You can ask your questions here in discussion forum also. You'll be able to get your leadership board here. Okay, so what is your rank? Like currently my rank is 1772. So you'll get to know whether what is your rank, okay, based on learning, based on assessment, assignment, everything. Okay, it'll be good to learn about. I'll just provide you the coupon code here. It's free Python. Once you'll click on enroll option, it may ask you the fees, right? So there you can apply this coupon code free Python. I just entered this on chat box. Better to just use it. Even if you are interested, I mean, if you think whether your students, whosoever is interested, you can pass this thing to them as well. Whosoever wants to learn Python, they can come on this platform and learn. And my email ID, okay, so I'll just provide my email ID, and we can connect on LinkedIn. In fact, I would suggest one more thing. Like, we have YouTube channel where entire course is available. Show you. We'll go in playlist. So couple of courses are freely available here, and those are totally online, and an entire course like deep learning and machine learning, Docker, Kubernetes, C programming, Linux, Python programming, right? Couple of projects also, Kubernetes, embedded system, IoT, right? So you can go on YouTube channel with a name called Learn and Build, and definitely you can just go on playlist and learn everything about. And this way I could ask you to just subscribe this channel as well. Okay, so this is my profile with the name Saurabh Bharadwaj. Okay, and we can connect over LinkedIn. If I'll share my profile as well, sharing this link of my profile on chat box, sharing my contact details as well. So my this is the recent product that we have built with a name called Learn and Build. It's a platform for e-learning, having lots of parameters or features inside. We have our own app using app, on Google Play Store, you can download that thing in your screen as well. So that's it, I guess. I tried covering this. I tried to cover this thing in this session. I hope I have just covered a session or informative session which might help you in understanding this domain.
Thank you, Saurav sir.
Thank you, sir.
Amit here.
Yes, sir.
Yeah. So, dear participants, I hope we all have learned a lot of things in this session. And Saurav sir shall also take another session, and the session will start at 2:30. We will have a lunch break, and then